back to Never Trust an Atom and my new series, An Introduction to Astronomy and All Things Space. Stay tuned to learn about some common misconceptions, where we are in the universe, and what those cool space words you hear in documentaries actually mean. We live on planet Earth, which whizzes around the sun at a whopping 30 kilometers a second. The path it follows is the Earth's orbit, and this is roughly circular. The other major planets that you learn about in school, Mercury, Venus, Mars, Jupiter, Saturn, Uranus and Neptune, also have roughly circular orbits at set distances. Smaller objects like asteroids or comets can have much more elliptical orbits, and they can interact with each other gravitationally, changing their orbits over time. We tend to find them out in the asteroid belts between Jupiter and Mars, or in the Kuiper belt which is beyond Neptune. Sometimes these gravitational interactions can kick them in towards the inner solar system and perhaps even on a collision course with Earth. So planets are the big things and asteroids are the small things, but what comes between them? Well, that would be the dwarf planets, which accreted enough matter to become roughly spherical, but not so much that they have a large enough gravitational field to clear out of their orbits. The most famous example of this is Pluto, which was initially considered a planet, but was then discovered to share its orbit with a lot of other bodies in the Kuiper belt. Also, Pluto is actually smaller than quite a few moons, including our own. A moon is a natural satellite, something that orbits another object. So technically the planets are moons of the sun, but usually when we refer to moons, we're talking about the small rocky bodies that orbit a planet. Moons can either be captured, like Mars's tiny moons Phobos and Deimos, that look like and probably used to be asteroids that strayed too close to Mars and were captured by its gravity, or they can be formed by accretion, which is probably how the larger of Jupiter and Saturn's moons came to be. So all of this orbits the Sun, which is a star. And all of the stars that you can see in the night sky are like the Sun, but a lot further away. They form when a giant cloud of mostly hydrogen gas and dust becomes slightly too dense in one place and collapses in on itself under its own gravity. As the density increases, the temperature does too, until the hydrogen atoms are moving so fast that when they collide, they undergo nuclear fusion, releasing energy and forming helium. The energy that is released is in the form of electromagnetic radiation, or in other words, light. Around the star, the leftover gas and dust forms a disk, and the particles in it collide and stick together, which happens over and over again until it has enough of its own gravity to pull in the particles around it, eventually forming a planet. But not all of the particles form planets. Some of them just don't grow big enough, usually due to the influence of a much larger body nearby. For example, the asteroid belt didn't form a planet because of Jupiter's gravity. This process is how the majority of stars form, which means that most stars have planets. These planets are called exoplanets and can be very different from the ones that we know and love. There are Jupiter-sized planets orbiting closer to their star than Mercury does in our solar system. There are super Earths, and there are even planets made of diamond. So the planets and lots of other small things orbit the Sun, making up our solar system. And there are lots of other stars nearby with their own planets, so their own solar systems. And all of these stars are part of a much larger formation called a galaxy. Ours is called the Milky Way and has 100 billion stars. That's potentially 100 billion solar systems and countless planets. Some of the stars are like our Sun, called yellow dwarfs. Some are smaller, called red dwarfs, and others are much larger, called blue giants. These are all the names of different types of stars in the main sequence, which is where stars spend the majority of their lives. They all form in the same way, by the collapse of a giant cloud of gas and dust called a nebula. But as they age, their paths diverge, and they all die in different ways depending on their size. The blue giants are the hottest, so burn their fuel, the hydrogen gas, extremely quickly before collapsing in on themselves and going out with a bang, a supernova. The bigger stars leave a black hole and the slightly smaller ones a neutron star. Stars like our Sun will swell into red giants before slowly shedding the outer layers and creating a beautiful nebula with a white dwarf at the centre. And the smallest but most common type of star, the red dwarfs, will outlive all of the other main sequence stars by billions or even trillions of years. All of these stars orbit the galactic centre, the densest region of stars. And in the middle of it all is a supermassive black hole. And we think all galaxies have these, but it's not yet clear if they were there before the galaxies or as a result of the galaxies. But did you know, not all galaxies look the same? Some form beautiful spiral shapes like us and our neighbouring galaxy Andromeda, others huge elongated spheres, and some are just completely irregular. The irregular galaxies are usually that way because of gravitational interaction. For example, if they're about to collide with another galaxy, or are a dwarf galaxy orbiting a bigger one. Astronomers think that spiral galaxies are just one of the first stages of galactic evolution, and that all will end up as elliptical galaxies after they have collided and coalesced with those nearby. That also explains why the elliptical galaxies we observe in the universe tend to be much larger and older than the spiral ones. Expanding out from galaxies, we can see that the universe is further organised into galactic clusters, superclusters, and eventually the cosmic web. The filaments you can see here are where the galaxies are found, and between them are these huge voids. This happens because the universe is made of more than what we can see. In fact, only 5% of the universe is made up of normal matter. The rest, you ask? Well, that's the dark matter and dark energy. Dark matter is what causes the filaments, as its gravity draws in the normal matter, and we have a few ideas of what it could be, but nothing is proven yet. Dark energy is a totally different story. It takes up 70% of the universe, but it doesn't interact with anything. We only know what it does, and what it does is cause space to expand. The balance between dark matter and dark energy dictates the future of the universe. If there's more dark matter than dark energy, then expansion will slow and the universe could even collapse back in on itself. But if dark energy rules, then the universe could expand forever, until the sky becomes void of stars and even atoms are ripped apart. This sounds kind of scary, but you don't need to worry because this will be many billions or even trillions of years in the future. So, from the solar system to stars and cosmology, I hope you've enjoyed this whistle-stop tour of the universe. Space is awesome and there's so much I've missed out here, so look forward to some more in-depth and focused videos in the future. So leave a comment with the topics that you want me to cover. Thank you so much for watching. Stay curious, guys, and see you next time.